3 billion years ago, this planet had rivers, not just puddles, not just frost, rivers, lakes, and possibly oceans. So what happened, and more importantly, in all that water, was something alive? For most of human history, Mars was just a red dot in the night sky. Mysterious, distant, dead, or so we assumed. When our first probes finally got close enough to look, they found something that stopped scientists cold. The land was shaped by water. Valley networks stretching thousands of kilometers. Channels carved as if by floods of an unimaginable scale. Shoreline-like features wrapping entire regions of the northern hemisphere. The geology was screaming one thing: liquid water was here. But that raised a problem. A deep, almost philosophically unsettling problem. Billions of years ago, our sun was roughly 70% as bright as it is today. Mars, already farther from the sun than Earth, should have been a frozen wasteland, a ball of ice, permanently. So how did liquid water exist at all? Scientists call this the faint young sun paradox. It's one of the biggest unresolved questions in planetary science. And the answer, whichever answer turns out to be correct, completely changes how we think about life in the universe. Was Mars once genuinely warm and wet, with a thick atmosphere trapping heat like a greenhouse? Was it mostly frozen, occasionally thawed by volcanic eruptions that briefly melted the surface? Or did liquid water exist only underground, shielded from the cold by layers of rock and geothermal heat? Scientists are still debating this. But over the past 2 decades, 3 extraordinary machines have been sent to Mars with one singular mission: follow the water. And what they found changed everything. January 2004, NASA's Opportunity rover bounces to a landing inside Eagle Crater, Mars. The mission was planned to last 90 days. It lasted 14 years. In that time, Opportunity traveled over 45 kilometers across the Martian surface, the equivalent of a marathon and a half, slowly piecing together a story that had been buried in rock for billions of years. The first major clue came almost immediately. Inside Eagle Crater, Opportunity's instruments detected something extraordinary: spherical gray pebbles embedded in the rock. Scientists nicknamed them blueberries. These weren't random rocks. These were hematite concretions, tiny mineral spheres that on Earth only form in one place: sediment that has been soaked in water. The comparison to formations found in Utah was almost identical. It was the first hard mineralogical evidence that Mars didn't just look like water had been there. Water had absolutely, definitively been there. But Opportunity wasn't done. Years into its mission, while exploring the rim of Endeavour Crater, the rover made a discovery that upgraded the entire conversation. A bright vein of gypsum, running straight through a rock face. Gypsum is a calcium sulfate mineral. On Earth, it forms when water flows through calcium-rich rock and deposits minerals as it moves. This wasn't ancient residue. This vein was deposited by water that had flowed through that rock crack. NASA scientists described it as among the most powerful evidence yet for liquid water on Mars, because unlike other minerals that can sometimes form without water, gypsum veins essentially require it. Even more significant was the chemistry. Analysis of clay minerals found nearby revealed something crucial. The water that had once moved through this region was neutral pH, not highly acidic, not corrosive, the kind of water that on Earth life drinks. In fact, it was chemically closer to the groundwater that flows beneath farmland than to the sulfuric acid found in some of Mars's other ancient water environments. Opportunity had found something extraordinary. Evidence not just of water, but of water that could have supported life. February 18th, 2021. A 1-ton nuclear-powered laboratory the size of a car is lowered on cables by a rocket-powered hovering crane onto the floor of a 45-kilometer-wide crater. This is Perseverance. And the location was no accident. Jezero Crater was chosen because from orbit it looks unmistakably like an ancient river delta. That same fan-shaped sediment deposit you'd see at the mouth of the Amazon, the Nile, the Mississippi, where a river slows down and drops everything it's been carrying. The resemblance is not subtle. It is stunning. Scientists believe that billions of years ago, a river flowed into this crater, filling it with a lake. Over time, it deposited layer upon layer of sediment, and possibly, preserved within those layers, the chemical signatures of ancient life. Perseverance carried with it a companion that had never flown anywhere other than Earth. Ingenuity, the first powered aircraft ever to fly on another planet. Ingenuity wasn't just a technology demonstration. It became a scout, flying ahead of Perseverance, mapping terrain, helping scientists decide where to drive. Together, they began drilling. And what came out of those drill cores shocked the science team. The floor of Jezero crater is made of volcanic rock, igneous basalt, formed by ancient lava flows. That alone was surprising. Scientists had expected sedimentary rock from the lake. But here's where it gets remarkable. The volcanic rock had been altered, threaded through with carbonate and perchlorate minerals, compounds that only form when water interacts with rock over extended periods. The lake had been here long enough to chemically rewrite the volcanic floor beneath it. This wasn't a quick flood. This was sustained water, a lake that lasted, potentially, for millions of years. When Perseverance finally drove up to the base of the ancient delta itself, it found exactly what the geologists had hoped for: beautifully layered sedimentary rock, the kind that, on Earth, preserves organic material for billions of years. Perseverance detected organic molecules in several samples. Now, and this is critical, organic molecules do not automatically mean life. They can form through purely chemical processes. But they are the building blocks. They are what life uses. And finding them in an ancient lake bed, in rocks that were soaked by water for millions of years, in a mineral environment chemically suited to supporting microbial life, those samples are now sealed in titanium tubes, sitting on the Martian surface, waiting for a future mission to retrieve them and bring them to Earth. The greatest treasure hunt in human history has already taken place. We're just waiting for the delivery. While NASA was drilling craters in the south, China's space agency was quietly making history in the north. Zhurong rover, named after the Chinese god of fire, landed in Utopia Planitia in May 2021, a vast, flat plain in Mars's northern hemisphere. To most people, it looks like nothing, flat red emptiness stretching to the horizon. But the data told a very different story. Zhurong was equipped with ground-penetrating radar. It didn't just see the surface of Mars. It looked through it, down through meters of rock and sediment, building a picture of what lay beneath. And what the radar revealed beneath Utopia Planitia was unlike anything seen before. Buried underground, inclined sediment layers, sloping, angled, extending outward from the edge of the plain. Geologists immediately recognized the pattern. On Earth, you see this structure in exactly one place: ancient shorelines. When waves repeatedly wash over a beach, they build up these characteristic sloping sediment layers, deposited by the water, shaped by the tide. Zhurong had found what may be the fossilized imprint of an ancient Martian ocean's shore. Not a lake, not a river. An ocean, one that may have covered as much as a third of the entire planet. Scientists call it the Paleo-Ocean hypothesis. The idea that Mars's entire northern lowland was once filled with water, an ocean potentially deeper than the Mediterranean Sea. Zhurong's discovery didn't prove the ocean existed beyond all doubt, but it added a powerful new piece of evidence to a puzzle that was already looking increasingly clear. Mars didn't just have some water. Mars may have had a planetary ocean. So let's step back. 3 rovers, 3 different regions of Mars, 3 completely independent lines of evidence. Opportunity found minerals that only form in neutral, life-compatible water. Perseverance found an ancient lake bed with organic molecules in rocks chemically altered by millions of years of water contact. Zhurong found what appeared to be ancient ocean shorelines buried beneath the northern plains. Together, they paint a picture of a planet that was, for at least 1 billion years, genuinely wet. Not marginally, not just underground. Rivers, lakes, deltas, and possibly vast northern oceans with real tides and waves. Which brings us back to that paradox. How? The leading theories today suggest a combination of factors. A thicker early atmosphere, rich in carbon dioxide and possibly hydrogen, creating a greenhouse effect strong enough to keep temperatures above freezing. Periodic volcanic eruptions that released enormous amounts of heat and gas, temporarily warming the surface enough for liquid water to flow. And perhaps most intriguingly, subsurface geothermal systems that kept water liquid underground long after the surface had frozen over. Whatever the mechanism, it eventually ended. Mars lost its global magnetic field. Scientists believe its iron core cooled and solidified. Without that magnetic shield, the solar wind began slowly stripping Mars's atmosphere away. The greenhouse effect weakened. Temperatures plummeted. The water, most of it, left, frozen into polar ice caps, trapped underground, escaped into space as water vapor. The planet we see today is the corpse of a world that was once far more like our own. Here's the question that keeps astrobiologists up at night. We know Mars had the water. We know it had the chemistry. We know it had the time. On Earth, life appeared remarkably fast after conditions became suitable. Microbial life was thriving here within a few 100 million years of Earth forming. Mars had similar conditions, possibly for over 1 billion years. If the same process that sparked life on Earth is not uniquely Earth-specific, then somewhere in those ancient lake beds, those altered volcanic rocks, those buried shorelines, there may be a fossil, a microscopic imprint, a chemical ghost. The answer may already be sitting in one of those sample tubes. We just haven't opened them yet. Mars is no longer a mystery of whether water existed. The water was there. The science is overwhelming. The mystery now is life. 2 planets, formed from the same cloud of gas and dust, both with liquid water in their early histories. One teeming with life, one silent for now. The Mars sample return mission is still being planned. Perseverance's tubes are still waiting. And somewhere beneath that red dust, the answer is waiting too. Now I want to hear from you. Do you think those samples are going to come back positive? Do you think Mars once had life, or do you think Earth got uniquely lucky? Drop your take in the comments. This is one of those conversations I genuinely want to read. And if this kind of deep dive science is what you're here for, hit subscribe and turn on notifications, because we go this deep on every single video. The next one is already going to blow your mind. We'll see you there.